and it's about inverses. So basically, for before when you were in Algebra 1, for inverses, they gave you, let's say, a pair of coordinates, 2, 1, and the inverse of the coordinates would be 1, 2. This is a little bit more depth. So you're going to be doing equations. You're going to be doing this algebraically. You're going to be doing this graphically, and not just with coordinates. All right. So for inverses, the x value of the original relation. This is a relation. This set of coordinates. It's the new y value for the inverse. That's how it works. The y value for the original relation is the new x value. It's the new x value. That's how it works. All you're doing is switching it. I could use more formal language, but you can't because you're going to be getting this like less formal language because you're going to get this kind of language. So I'm gonna do the first one with you. I'm gonna write the inverse of the relation, given the ordered pairs by switching x and y. So they ask you for a couple things. First of all, is it a function? Yes or no? Are there repeating x values? No. So it's a function. All right. Then they ask you for all the domain. If you're struggling with domain, just label your points: x and y, x and y, x and y. Set notation when you're doing domain arrangement this way for individual points. We rarely do it, but close bracket, x bar, x equals, all my x values, 3, 6, 9, close the curly bracket. For my range, close bracket, y bar, because we're talking about y values, y equals 5, 10, 15. We don't do curly brackets for graphs because it's just too much. You can't count all those points in between. Now, the next part, they're asking you for the inverse. All you need to do is switch all the x's and y's. Looks the same on the outside, curly bracket, but the points change. 3, 5, 5, 3. It's easy when you're given this kind of problem. 10, 6. 15, 9. Close all those parentheses and the color brackets. And then just check if that inverse is a function. If there's repeating x values. If you look at your original y's, there's no repeating. So you're right, this is a function. For your domain, it's just switched. Everything is switched. Y values come over here, and it becomes x bar, x equals 5, 10, 15, close curly bracket. Range becomes y bar, y equals 3, 6, and 9. Try the second one on your own. That's not my fault.
She walked in here. I did not know that. I did not. I was in the bathroom.
Recording.
Again? Sorry.
Alright guys, let's do it. Alright, so look at number, 2. Is that a function?
No.
What repeats?
2.
2. 2 repeats. So this is not a function. The range in the domain, for my domain, curly bracket, x bar, x equals 2, 3. You don't have to write repeating values more than once, unless you want to. You can, but you don't have to. The range, negative y bar, y equals -3, -4, 0, 7, close curly bracket. For the inverse, you just switch all the x's and y's. So here, -3, 2, 3, 4, -4, 3, 0, and 2, 7, and negative. Is this inverse a function? There are no repeating y values in the original, so yes, this is a function. And your new domain, just your old y values. So x bar, x equals -3, -4, 0, and 7. Close curly bracket on both sides. My range, curly bracket, y bar, y equals 2, 3, and -4. The next part is going to be the inverse of functions, and we're going to be solving for a variable. We're going to be switching x's and y's. Okay? So for functions, we typically use notations such as f of x or a of s or g of x. This is pretty important stuff right here. Typically use that kind of notation. If I wanted to notate the inverse, you're using a -1 superscript. So f of -1 sub x, a to the -1 sub x, g to the -1 sub x. That's what the inverse looks like. You use superscript to the -1 power. That's what it looks like, but it's not a power. It's just shorthand for noting an inverse. So we're going to find the inverse of each function. We're going to find f to the -1 of x. Okay? So first, the steps. You're going to have to refer to this. This is the one homework I'm not going over with you. Change f of x to y. So this becomes y equals 2x plus 4. Okay? Then you're going to switch the x and y variables. Switch the x and y variables. Look at your paper. Look at the directions. X comes over here. I'm switching them. Equals 2 times y plus 4. Make sure you have a little bit of space on the left of x. A little bit of space on the left of x. Read the next directions to yourself. Now, solve for y. How do you get the y term by itself? Add or subtract first. Subtract 4. Subtract 4. Make a little note. Add, because you're going to have to be doing this. Or subtract first, then, that means then, multiply or divide. Okay? Coefficients. So we're going to subtract 4 first. So subtract 4, both sides. Can I combine -4 with x? No. Both just come down. I get -4 plus x equals 2y comes down. And 4 minus 4 just goes away. Now what? divide by 2. This is how I want you to divide. You're in algebra 2 now. You divide individual terms. Okay? Simplify. What's negative 4 divided by 2? What kind of 2? Plus x over 2 equals y. Now, it says change y to f to the negative 1 sub x. So you just rewrite it. F to the negative 1 sub x. I know it's turned around. We're just going to flip it. Equals negative 2 plus x over 2. And just to get a little practice with your graphing, or at least acquiring points, please, if you don't have a calculator, get one, but go to your graphing calculator, and you're going to put in negative 2 plus x divided by 2. Go to y equals, put in the equation you just found. Get the value, the points. If you don't know to do fractions, I'll have to do it with you. So I go to y equals, clear out what's in there, put in negative 2 plus alpha, y equals, enter, x over 2. You go to the graph, second graph. Don't use fractions. Nobody wants this. Nobody wants these points. Pick any points but fractions. You can start anywhere you want to on the x values. But fill in the table is there. So negative 4, negative 4, negative 2, negative 3, negative 4, negative 4, negative 2, negative 3. Finish the table. I skipped all the ones with fractions. Who wants to graph those kinds of points? Okay? Finish the table. When you're done with that, go ahead, do this one.
We're not even the table around.
Say. No, it doesn't have to. It doesn't have to start in the same place, right? You got that. What do you do first in the next one? Look at it. Go ahead and get started on the next one. Change f of x to y. Change f of x to y. Excellent. Oh, this is the calculator. It's not you. It's the calculator. Perfect. Perfect. It's perfect. It's fine. It's fine. But no decimals, no fractions. Alright? Just skip the ones with fractions and decimals. Alright guys, we gotta move on. We gotta move on. You can come back and do that. So, for the second one, the first step, change f of x to y. It becomes y equals 9 minus 4x. Step 2, switch the x and y. Please don't tell me you can't do this at home. You have the directions. You have the directions. You're going to do this for number 2, 3, 4, and 5 on your homework. So you switch them. X equals 9 minus 4 times y. And then you're just solving for y. What do we do to solve for the y term? Subtract 9 on both sides. This x is positive. This becomes negative 9 plus x. I had to move it over a little bit, sorry. 9 minus 9 is 0 equals negative 4y. How do I get the y term by itself? Divide by negative 4. All the way across. Okay? You should get y equals negative 9 over 4 plus x over negative 4. Sorry. Negative 9 over negative 4 and x over negative 4. If I do the last step, I change y to f to the negative 1 of x. It's f to the negative 1 of x equals 9 over 4. A negative over a negative is positive. Minus, I bring that negative up, minus x over 4. That's my final equation for the inverse. The points off the top of my head, I'm going to say 1. That's all I know. Okay? The rest of them, you know how to use your calculator now to put equations in to get to the table. All right, I feel good about that. The rest of them you can get on your own. Okay? We do need to move forward. Okay? So for graphs of inverse relations, moving on. You can do that part later, guys. Come on. For the graphs of inverse relations. So essentially what all this is saying is you switch the x and y coordinates. You can switch the x and y coordinates. And the values are switched. That's all that says. So if I graph 1, 0, the inverse of that point would be 0, 1. It would be right over here. This is my inverse. Okay? A characteristic of inverses is if you draw a horizontal line, it's kind of like the vertical line test for functions. If you draw a horizontal line, that line should only hit both graphs at one point. So if I go up, it should only hit this function at one point, both functions at one point. This one works. These are inverses. But over here, this hits this graph at like 3 different locations, maybe 4. Hits it here, 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 and here. So 3 different locations. These are not inverses. This is an example of not inverses. Draw a horizontal line, not inverses. Hits more than once. On a horizontal. These are inverses. Are there cases where you would have to use that? You could. It's easy than identifying distinct points. So while you're doing that, for the next one, we are going to graph the original equation. We're going to highlight green, the original, and then we're going to graph the inverse. We're going to solve for the inverse and just graph it. It's a straight line. What's the y-intercept? We're not going to use the calculator. What's the y-intercept? Y-intercept is -1. Our slope is 3. So for this one, my y-intercept, b, is -1. My slope is 3. I'm going to create a fraction, 3/1. So that means I'm going to go up 3 and right 1, make another point. Okay, this is algebra 1. So we can move fairly quickly. So I made my first y-intercept right here. So -1, this is the y-intercept. And then I go up 3 units. 1, 2, 3, right 1, make a point. Up 3, 1, 2, 3, right 1, make a point. I want to go back the other way. Go down 3, 1, 2, 3, make a point. And I just connect all the dots. And then I'm going to label this line. You're going to label this line. You know how to do this with your graphing calculator, but this is so much quicker for us right now. So this is f of x. And you're going to take your highlighter. This is f of x equals 3x minus 1. You're going to take your highlighter and highlight this line. Okay? That's f of x. Now, we could go find the inverse algebraically, which we are going to do, but we're going to use the points we just got and switch them. So right here, this is 0. I'm going to label these points so it's easier for you. This is 0, -1. The new point for your inverse is going to be -1, 0. Right over here. This is the inverse I'm graphing. Do it with your pencil. Shouldn't be highlighted. Don't highlight it. Get the next point. Use one of the other points. What are the coordinates? All right. What's another point? 1, 2. So the inverse would be 2, 2, 1. Okay? This is for inverse. But don't highlight it yet. Okay? So 2. So right 2, up 1. That's my another point. And it looks like I'm going right 3, up 1. I'm going the opposite. And I have 2 points. I have my 2 points. I'm pretty good. I'm pretty set. I can use the ruler. And I can connect the dots. This is my inverse. I'm going to label it the inverse. And then I'm going to find out what it is algebraically. Okay? But not yet. Highlight it first. It's orange. That's my inverse. We did it graphically. We got those points graphically. Switched them, plotted the points. Okay? Now, it says find the inverse algebraically. If this is on your test, you need to follow all of the directions. You need to follow all of the directions. So algebraically, I'm going to write the steps while you're doing that. We're going to switch x and y. Solve for y. And then write it in terms of it being the inverse. Okay? So for my original equation, I have y equals 3x minus 1. we're going to find that we end up with a slope of 1/3 for our inverse. So I switch x and y. Here's x equals 3 y's minus 1. Solving for y, I add 1 to both sides. And plus 1 comes down, plus x comes down, equals 3y's. This goes away. Divide by 3 all the way across. Okay? Final answer. I'm going to simplify this. I get y equals 1/3 plus x over 3. Or f to the negative 1 times x, or sub x, equals 1/3 plus x over 3. This is my inverse. This is what I just graphed without having to solve for it. This equals 1/3 plus x over 3. So what we're getting to, you're going to be composing functions. In order to compose functions, 2 functions are needed. Typically the function and its inverse. So the composition of that occurs by replacing one function into another. That's what we're going to be doing. We're going to be replacing another function into another. So this little symbol is used to represent composition. It looks like multiplication. It's not. It's a type of multiplication, but it's not exactly. Basically what you might see f of x, 2 different functions, that symbol that looks like multiplication, g of x, and what that means is you're replacing this function right here. All of it goes inside of the x value. Okay? So it's going to look like this. F of parentheses, g of x, close parentheses. We're replacing the x value in this function. So look at the problems. It's given that f of x equals 2x and g of x equals x plus 4. We're going to replace, this represents f of g of x. Okay? What does f of x equal? Get through, look what is given. What's f of x equal? 2x. So you're going to write 2 and put a big parentheses. What's g of x? X plus 4. You're replacing the x value with x plus 4. And then you're going to simplify. You're going to simplify. What's 2 times x? 2x. So if you can't remember how to distribute, you distribute the 2 to the x, it becomes 2 times x. And then you distribute the 2 to the 4, it becomes plus 2 times 4. Final answer, 2x plus 8. This is your final answer here, okay? That's what a composition does. In the middle, we have h of x equals times composed to g of x. And you write it out. What's going inside of h? G of x. So write out h. We have 3 times that g of x minus 2. So you insert g of x. X plus 4. And you're distributing again. Okay? It becomes 3 times x, plus 3 times 4 minus 2. Okay? You get 3x plus 12 minus 2. What's 12 minus 2? 10. This equals 3x plus 10. The last one, we're composing f of x and h of x. So we have f of h of x. It's going inside. The second one always goes inside the first one. Now, f of x equals 2x, so 2 times something. 2 times something. 2 times what h of x is. It's 3x minus 2. Distributing. 2 distributes to 3x, so 2 times 3x's. And then the 2 distributes to negative 2 plus 2 times negative 2. You simplify. What's 2 times 3? 6. And the x just comes down. Plus 2 times negative 2. Easy peasy. Almost done. Almost done. Almost done. Okay? I think the next part is we're just switching values, or we're putting values in values. All right. So for we're gonna go over this when we get back. I want to do this part. You still need those highlighters. All right. So to compose a table of values, use the table like a map. All right. You start on the inside. You start on the inside. What's inside of f? X, the next value, but g of negative 2. We're going to start on the inside. We're going to find g of negative 2 first. Okay? So x equals negative 2 here, right? Go to where x equals negative 2 in the column. What's the y value for g? Go to where x equals negative 2. For g, 1. 1. So basically, we start on the inside, we find g of negative 2. It's 1. Now, to get the full answer, I need f of what this number is. So I need f of 1. When x equals 1, what is the f value? Go down, it's 3. This is 3. So we start on the inside, and then we move out. The end result will be a new y value. Okay? So on the inside, I have f of 3. So I'm going to start at where x equals 3. But I'm going to look in the f column. So start where x equals 3. What's the y value? 4. So we write 4. We're looking for g of this number. So g of 4. Go down to x equals 4. G of 4 is 2. Easy peasy. Try the last two. Yeah? For what? Can we go? Can't do it with you? So first, x equals 0. I go down to where x equals 0. I'm looking in the f column. It's 1. And then I want to know what f of 1 is. You can do that. X equals 1. F is 3. Like a map. It's like a map. Oh, did I do it right? This is 2. This is 3. Next one, I have g of negative 4. Go to where x equals negative 4. I get 3. And then I go down to 3, and I get g of that. 0 is my answer. Okay? So problems like that would be one and eight. Number eight. Number eight and four. All right, we got time for the last one. Yeah. So determine whether two equations are in by composing both sets of equations in the form f of x, g of x, and g of x, f of x. Both equations, both compositions have to equal x. Okay? They have to equal x. So here, I'm going to put g of x inside of f. So they have to equal x, both of them, the compositions, in order for these to be inverses. So it's going to take a lot of space, guys. So I'm going to use this space over here. So 5, what goes inside? X plus 4 over 5 minus 4. If this equals x, I'm on my way to showing that these two are inverses. This is how you prove that two equations are inverses. What's 5 times x? Oh, well, these just cancel. One's on the top, one's on the bottom. They just cancel. And you're left with x plus 4 minus 4. What are your like terms? 4 and 4, they just cancel, right? And I'm left with x. So if this equals x and this equals x, these two are inverses. That's what we're trying to prove. So we got to do the reverse. We have to put x plus 4 divided by 5, g of x. We're going to put f of x inside. So I have x plus 4. I'm just going to leave the x blank. Put plus 4 over here. And put my 5 down here. All right. F equals 5x minus 4. What are my like terms? And negative 4. These cancel, and I'm left with 5x divided by 5. What happens to the 5s?
Cancels out.
Cancels out. What am I left with? So your final answer. These are inverses. These equations, actually f of x and g of x are inverses, period. You have to learn how to do this, okay? Last part, and then it's a wrap. Next page. Compositions are determined graphically. The stuff we did just before, we're going to do with a graph, okay? What does x equal right here? 3. I want to find f of 3. So let me figure out which one is f. This one. Label this f of x. This is h of x. This one's h. That's f. So graphically, when x equals 3, what is the y value on the blue line? 0. So this one's, yeah. This one's blue. This one's red. The next one, when x equals negative 2, what is the y value on the red curve? Negative 2. I have 2 answers. This one, oh, sorry, when x equals, my bad. Over here, 0. Okay? For f of negative 5, so go over to negative 5. What's the y value on the blue line? What's that y value? 8. So I'm going to come out here. F of -5 equals 8. What's h of 8? Can you tell? Does it show up on the red curve? I can't tell. No, it doesn't show up. We can't tell. Tell you what. Make a little note. Practice this. Next class. Homework tonight, though. Please do it. Please do it. You have everything you need. Don't make me sad. I already got tears. Monday's the review, and we're going to practice doing compositions graphically. That's it. I won't be here Monday, so you'll be using a video if you need help. Okay? Huh? I have a meeting. I'll be it. I'll get this. And I won't be here Monday afternoon because of that, so. But I will be here today.